brought to you by Pieces123.com. I learn and teach online.
Here's the next question. Number 21. Consider a system consisting of a synchronous generator working at a lagging power factor, a synchronous motor working at an overexcited condition, and a directly grid-connected induction generator. Consider capacitive VAR to be a source and inductive VAR to be a sink of reactive power. Which one of the following statements is true? Let's go through the options given. Synchronous motor and synchronous generator are sources. An induction generator is a sink of reactive power. Second one says, synchronous motor and induction generator are sources and synchronous generator is a sink of reactive power. Next, synchronous motor is a source and induction generator and synchronous generator are sinks of reactive power. And all are sources of reactive power. Okay, so the first thing is, let's put it all into perspective by drawing out a figure. So consider a system consisting of a synchronous generator. Let me draw a very small diagram here. So we have a generator working at a lagging power factor, a synchronous motor. Okay, then we have a motor here. And finally, we have an induction generator. Alright, so an induction generator, motor and generator all connected to each other. The conditions given in the question is the key. Okay, so since they are talking about VAR, let's call this as Q1, Q2 and Q3. Okay. Alright, now according to what's given in the question, the synchronous generator is working at lagging power factor. That is what is given here, generator working at lagging power factor. What does that mean? It means that the generator operating at lagging power factor is in fact an inductive load should be connected. So an inductive load when connected makes the machine to generate reactive power to the lagging load. Alright, so that means that the reactive power would be this way. Then we have the synchronous motor. Now the question says that the synchronous motor is overexcited. Now the condition when the synchronous motor is overexcited is it starts acting like a synchronous condenser. So I suggest you keep that in mind as well. It's a good point. Synchronous motor, when overexcited, acts as a synchronous condenser. Okay, and finally we have the induction generator. Now the induction generator over here, directly grid connected induction generator. Okay, so the induction generator will absorb the reactive power that has been developed in the magnetic field. Okay, so that means that we have both of these coming here, right? So this tells us that the synchronous motor and the synchronous generator, look at this node over here. Once you have determined exactly which way the VAR moves or the conditions for each machine given in the question, once you have the idea of what it represents, then you can say which ones are the sources and what constitutes the sink. Okay, let's go over this one more time. Generator operating at lagging power factor. So there is an inductive load is connected, which means that the machine will generate reactive power to that load. Then we have the synchronous motor which is overexcited, which acts as a synchronous condenser. And then the induction generator will absorb all of the reactive power that is developing. So this is absorbing. Now because it is absorbing, it is a sink. Okay, so the induction generator is a sink. You'll have to think of this in terms of just the English meaning as well of a sink. A sink is something that absorbs, something that it pulls in. So you will see from this figure here that Q1 and Q2 go through to Q3, which is absorbed into the induction generator. So synchronous motor and synchronous generators are the sources, while the induction generator turns out to be the sink in this situation. So the right option here is A. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.